computer science or whatever, if you guys learned about the order of operation that logic works. But I'll just write this up just in case. But the way that logic works, like precedence, parentheses first, nots, ands and ors, and then if-thens.
Is there a precedence between the ands and the ors?
No, you just go from left to right. It's sort of like addition, subtraction, multiplication, division. That's a good question, yeah. So if you guys ever have like a program that you're reading, okay, or you have to develop a program, and eventually some of you guys are probably going to take like algorithm analysis, and you have to figure out like how fast the program runs. This is important to figuring out how fast the program runs, because you have to figure out the order of operations to that, okay? So. But I guess nowadays it really doesn't matter how fast it runs because the computers just are so fast. So it's not like 1996 where I crashed the computer every time I tried to run something. So regardless. Okay. So any other questions I can answer for you guys about this before we move on? Sir, please.
Can you do a different example with that for doing the Morgan alters?
Oh, I see what you mean. Do you mind? Okay, can you email me? And what I'm going to do is I'll post it on Blackboard for you. Would that be okay?
Yeah.
Okay, because just email me like specifically what you're looking for, like an example of the De Morgans first, and I'll just make one up for you and post it on Blackboard. Yeah, it never hurts to see more of these, I understand, but unfortunately we only have an hour and 20 minutes together. But I certainly will do that for you, okay? All right, other questions, guys? Okay, so the next thing we're going to look at, guys, is something called converse, contrapositive, and inverse of a conditional statement, okay? Throughout the course, we're going to be utilizing these ideas, okay? So, if I have a conditional statement, okay, like P implies Q, the converse, just flip those around, okay? So, let's say, if I study, then I will pass. If I flip that around, if I pass, then I study. That's the converse of that, okay? So, you're just flipping it around. The inverse takes the negation of both of the statements. So, if I study, then I will pass. If I don't study, then I will not pass. That's the inverse of that statement. The contrapositive both flips the statements and negates them. Okay, so that would mean if I study, then I pass. If I don't pass, then I did not study.
Oh, so the conclusion goes before.
Correct, right. The conclusion and then the antecedent would be flipped. Okay? All right. Of these three, the contrapositive is actually logically equivalent to the original condition. Okay, so in fact, in the second part of the course, when we start to do proofs, we're actually going to do something called an indirect proof by contraposition. Okay, so just put this on the back burner for now. I'll probably ask you guys again later, which is logically equivalent to the original statement. It's the contrapositive. And by the way, if I wanted to prove that, couldn't I just make a truth table and prove it by truth table? Okay, you guys can go home and do that if you want to, or you can just believe me. Okay, but probably believing me is the good one in this. All right, so let's just do a couple examples. We're going to write the converse, inverse, contrapositive, much easier than the Boolean algebra stuff. Okay, so if I study, then I will pass. I just said that one out for you guys, but let's just write it up. So if I want the converse, I just flip the conclusion and the antecedent. So for the converse, that's if I pass, then I will study. Or then I study, whatever you want. The inverse of that statement says that if I do not study, then I will not pass. If I don't study, then I will not pass. And then the contrapositive, that flips them. So if I do not pass, or if I don't pass, then I do not study, or then I don't study. All right. So, easy as it gets, right, guys? There's no numbers in that problem. Okay, just logical stuff. So, one of the things also, guys, remember, it's still a conditional statement, so you still need if-then in there, okay? I always see a lot of students forgetting that it's still conditional, so you should write if-then in there. So don't forget, guys, it has to stay if-then. Okay. This second one is a little bit trickier, and generally students get this wrong because they forget to implement something. So it says, if I'm tall, then I drink milk or I'm good at basketball. Okay. Most people get the converse of this correct. Okay. So if I was to ask you guys for the converse of that statement, okay, somebody tell me what they think or what they know the converse of this to be, please.
If I drink milk or good at basketball, then I'm tall.
Perfect, okay? So, if I drink milk, hopefully it has Kahlua in it. If I drink milk, is it Friday yet? Or I'm good at basketball. Wait, why does it have to be Friday to drink? It's a Wednesday, right? Yeah, I can drink. Cool.
Happy Wednesday.
Happy Wednesday, yeah. Right on. If I drink milk, or I'm tall, or I play basketball. Then I am tall. Okay. And generally, most students get that one correct. Okay, that's not too difficult. Unfortunately, what happens is when they go to take the negations and they try to do the converse, the contrapositive and the inverse, that's where students go wrong with this. Okay, so if I was to ask you for the inverse of this, okay, does somebody think they might know what the inverse of this is going to be?
Right.
So go ahead.
So if I am not tall,
Okay, I like it.
then I do not drink milk and not good at basketball.
So if I am not tall, then I do not drink milk. Don't drink milk. And then you said one word in there that elated me.
And
So, end. Okay. Now, how come it goes from or to in, sir?
the law, that negation law, that
Not the negation, but it rhymes with a Lorgans.
De Morgan's law.
De Morgan's law. There you go. It was right on the tip of your tongue. Excellent, sir.
Thank you.
Okay. So, and. Okay, so remember, anytime you have a logical connector and you're taking the negation of it, you have to flip that connector. So instead of an or, then it becomes an and. I am not good at basketball. Okay. Does that make sense, guys? And this is where students go wrong with this quite often, okay? If I had $1 for every time a student did this wrong, I wouldn't be teaching anymore. Well, actually, I'd probably still be teaching, but I wouldn't be as poor. I'd just be slightly poor, okay?
You'd have an extra beer.
What's that, sir?
You'd have an extra beer every week.
Absolutely, more than a couple. Well, cheap beer. So, yeah. All right. And then obviously, guys, once you know that, the contrapositive is very easy, okay? In fact, for the contrapositive, all we do is we just flip the order of the inverse, okay? So, if I don't drink milk, and I am not good at basketball, then I am not tall. Let me give you guys a minute to copy down my chicken scratch. Okay. But does that make sense to everybody, guys? Any questions I can answer about that? Okay. Again, the reason we're doing this is because later in the course, we need to be able to write the inverse, we need to be able to write the contrapositive. Okay, so it's not like this thing that we do once and it's going to go away. There's going to be proofs that we have to do this within. Okay. All right. So the last thing I wanted to talk about today, which is going to take up a good chunk of what we have left, is going to be the arguments and argument forms. Okay. Basically, an argument is going to be a sequence of statements. Okay. So an argument is going to be a sequence of statements. An argument form is a sequence of statement forms. Okay, so an argument form And just to remind you guys the difference between a statement and a statement form, okay? This is a statement. This is a statement form, okay? So statement is just literally a variable. Statement form is when we start throwing the logical connectors in, okay? So it's not really much different than one another, okay? So basically a statement form, or an argument form basically is just comprised of statement forms. And this is really what we're going to be looking at.
What's the difference between statement and argument?
Oh, well, the argument is actually going to be something that looks like this, okay? Where you have a sequence of these, and then based on the sequence, and again, we're going to figure out if these are valid and invalid, okay? So, this is an argument, but basically if you wanted an argument would be this, P, Q, R, therefore T, okay? That would be an argument. This is an argument form because it starts throwing in logical connectors, okay?
Okay.
They're basically almost the same thing. Does that make sense, sir?
Gotcha,
It's a good
yeah.
question, thank you. Okay. All of the forms except for the last one are called the premises, okay? All arguments are based on premises, okay? So, these are the premises. And then the final statement or the final statement form is called the conclusion, okay? And what I put up here in a box, this is a very basic argument form, okay? The first two statements are the premises, the last one's the conclusion, okay? What we eventually want to do is we want to figure out, is the conclusion valid or invalid, okay? So, an argument form is valid if no matter what we plug in for the statement forms, that the conclusion is also going to be true. Okay? Now, what I'm going to do, guys, is I'm going to show you guys two ways to verify an argument form. Okay? One of which is going to be the truth table, the other of which is going to be able to use those basic rules of inference that are at the bottom of the sheet. Okay? So, much like proving equality between two statement forms, we have a brute force way, and then we also have a more sophisticated way. Okay, so let's take a look at the method you guys would utilize to verify by using a truth table. Okay, so if I have an argument form like this, I can determine if this is valid or invalid by using a truth table. Okay, so we keep going back to truth tables because they're so fundamental. What we're going to do is we're going to construct a table for all premises in the conclusion. Okay, so we just make a truth table for all three of these statements. Any row in which the premises are true is called a critical row. Okay, so basically all I'm going to do is I'm going to put a box around the critical rows. The conclusion is true in all critical rows. That is a valid argument form. Okay, so basically if you guys can make a truth table, you guys can do these problems very easily. Okay. So, let's do this, guys. Let's go through this one, okay? And then I'm going to let you guys try letter B on your own, just in case you guys were to see this on homework or see it again on a test, all right? So, let's just make a truth table for letter A. So, we're going to have our 8 rows. That's why we don't like truth tables, right? They're a bit of a pain in the ass. I think of truth tables like mowing my lawn. I can do it whenever I want. I don't necessarily like to do it all the time, but it's just painful to do. Sounds like math in general, doesn't it? P, Q, R. Then we have our 4 T's. Then we have our 4 F's. Blah, 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 blah. God, I have to do this for the next 35 years of my life. Awesome. You can write that on the teacher evaluation. So once we have our truth table together, then what we're going to do is we're just going to go through and we're going to make a column for each of the premises and figure out which are going to be the critical rows. Okay? So I always tell people just go through, okay, do the first one, and as soon as you get a false, just ignore it. Okay? The rest of that row. Okay? So the first premise we have is P implies Q. Okay, now, Somebody remind me, because that was, what, like almost 2 days ago, okay? When is the only time that the conditional is going to be false? Anybody remember, sir?
If the premise is false, the conclusion is true. I'm sorry, back is
Well, yeah, if you had true implies false, okay? Very good. So the only time that the if then is going to be false is if you have true implies false. So, true implies true, that's true. True implies true, that's true. True implies false is false, which means we're done with that row, okay? As soon as you get a false, it's not a critical row anymore. If it's not critical, who cares, okay? Because we only care about critical rows. Does that make sense, guys? It'll make your lives a lot easier, okay? True implies false is another false, so row number 4 goes away. And then as soon as the antecedent is false, you know that the conclusion is going to be true no matter what. So the rest of these are all true. Okay? So at least we've reduced our work by 25%. Okay? Let's see if we can reduce it a little bit more. Okay? Because the next premise that we have is Q implies R. Okay? Same game. What we're going to do is we're just going to say we're going to look at column Q and column R. Anytime true implies false, we're done with that. Okay? So Q implies R, true. True implies false, that's false. So now we're done with row 3, or row number 2 as well. Okay? We have true implies true for row number 5. That's true. We have true implies false for row number 6. So row number 6 has a false, and we're done with it. And then the last 2 of these rows, we have false implies true, false implies false. They have to be true. Okay. So, when it comes down to it, guys, don't we only have 4 critical rows? Okay? And that way we don't have to keep making truth tables for stuff. Okay? Or at least those rows, I apologize. Okay.